Positive 210. Remember, we're always going to start right here. Okay. Show me with your finger. This is called the initial side. So this is the initial side. And our initial side is always going to begin right here. Show me with your finger what quadrant the terminal side is going to fall. Terminal is where it ends. 3. You're right. So we remember, this is 0. This is 90. This is 180. This is 270. And when you get back here, this is 360. So the terminal side is going to rotate. And it's going to stop somewhere in quadrant 3. And the angle is bigger than 180, so it should look like that. It's more than half a circle. Well, the way I like to think of is which way did this swing? So you have to kind of imagine if this was animated, it would go counterclockwise. So it would go like this. It's not swinging clockwise like that. It's kind of hard, but imagine that it's a spinner. It's spinning here. So this is just showing like the range of motion, like which direction it swung. And wherever it ends, that is actually called the terminal side. So I haven't had a chance to look at your homework yet. Remember, the first homework is a Canvas assignment, but these are some of the questions. I'm trying to introduce some of the vocabulary that might be in that homework. Okay, negative 210. So again, this is my initial side. Now negative rotates clockwise. So this would be negative 90. This is negative 180. This is negative 270. This is negative 360. So my range of motion, everybody look at the screen. Now I'm swinging this direction. Okay, so this is my range of motion. Show me with your fingers what quadrant am I going to fall in for negative 210? Yeah, quadrant 2. So would it be just like that? So this would be my angle. Okay, so just like I told you yesterday, for angles, there's actually 2 units of measure. The first one is degrees. Now we're going to move on to the second one, which is a little trickier, and it's called radians. Okay, so let's go ahead. Let's talk about what is a radian. Radian is simply the measure of the arc over the radius. And I don't know if you remember from geometry, if you draw a circle and say this is my angle, this would be my arc. That's called an arc. Okay, a unit circle has a radius of 1. Does everyone see how we have a 1, 1, negative 1, negative 1? So the largest number we have on a unit circle is 1. If I were to draw a circle, a half circle, and if I were to measure the length of that half circle, I would get that the length is pi. And that's really, really important. Pi is the same as 180 degrees. So that's our unit conversion. So what I'm going to do now is I'm going to go around. So if this is pi, what do you think this is going to be? It's half a pi, right? If this is 180 and this is 90, half of 180 is 90. But to put it in radians, we would say that it is equal to pi over 2. For radians, we're counting by 1/2. Okay, so I start off at 0. Then I go to 1/2. Then I go to 1. And what is this going to be? What's 1 plus 1/2? 1.5. How do I write that as a mixed fraction though? 3/2. This is why I said that radians is a little bit harder. We're going to spend a lot more time on that because you have to be comfortable with fractions, because you're not like, I shouldn't even see a calculator on your desk. You don't get to use it, so you might as well put it under your desk. You don't get to use it. No calculators. Okay. And then what do you think 360 is going to be equivalent to? What'd you say?
You said 360?
Yeah, what is 360?
Wouldn't that be 0?
Not 0. It is 0, but if you go around 360 degrees, so if this is pi, what do you think this is going to be? What do you think 360 would be in radians? 2 pi.
Yeah.
So this is where things get a little complicated. But we just have to practice with it, because you're going to have to know how to convert fractions to decimals, or kind of just have an idea of where it would fall on the coordinate plane. We don't get to use calculators, so you have to do it off the dome.
Is this what's in the unit circle?
What'd you say?
Is this what's in the unit circle?
This is the unit circle. We're kind of getting started with it. A unit circle is just a circle that has a radius of 1. And I can't draw a perfect circle, but that's the unit circle. Now we're going to actually fill in what these angles represent. There'll be 3 angles in each quadrant, but we're not going to get there yet. We're not there right now. That's later. All right, so we need to graph these 4 angles. So I'll give you a minute to copy this down. And I think I'm going to do 2 at a time, or 1 at a time, because this is kind of, so let's just focus on pi over 4 right now. All right, so again, let's go ahead and label. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. So this is a little tricky, because what quadrant, show me with your finger, where do you think pi over 4 is going to fall? So this is kind of like saying 1/4. Do you think 1/4 is more than 1/2? Or do you think 1/4 is less than 1/2? Less than 1/2. So pi over 4, this is my initial side. Pi over 4 is going to be about here. That's pi over 4.
And do these also go around negative times?
Yep. So now let's talk about the negative. Just like with any angle, whether it's in degrees or radians, whenever it's negative, now we have to label going counterclockwise. But I need to erase A, so I want to wait so people have a chance to copy down A, so I can erase it and then move on to B. Everybody got A? All right, so now let's go ahead and do B. So for B, this is 0. This would be negative pi over 2. This is negative pi, negative 3 pi over 2. And then this is negative 2 pi. So we have pi over 3, negative pi over 3. Which is kind of like saying 2/3. Not 2/3, 1/3. So I don't say it out loud, but I want you to look at it and see if you can figure out. So you're trying to figure out, where would 1/3 fall? Is 1/3 less than 1/2 or more than 1/2? So show me with your fingers. I agree. What quadrant do you think we're going to fall in now? We're going to be in quadrant 4. because 1/3, if you think of it in terms of money, 1/3 is like 33 cents. 1/2 is 50 cents. 33 cents is less than 50 cents. So this angle is going to fall. It's going to rotate. This is my initial side. And it's going to rotate this way. And that would be my angle. All right, I'm going to give you a chance to copy down B, and then we'll move on to C. I'm going to redo D, though. So I'm going to change it to a different number for D, because we need to talk about a new vocabulary word before we go looking at that one. So go ahead, look at C. We got 4 pi over 4. It's positive. So it's positive. So 4 pi over 4. This would be 0. This is 1/2. This is 1. This is 3 halves. This is 2. Don't say it out loud. We got 4/5. We have to figure out what quadrant that is going to fall in. And I don't want anybody to say it. Don't show me your fingers yet. So we're starting here. This is my initial side. And it's rotating this direction. Where is it going to stop? Where is 4/5? So you're asking yourself, is it more than 1/2? If it's more than 1/2, it goes here. If it's less than 1/2. If you think 4/5 is bigger than 1, it would go here. If you think 4 over 5 is bigger than 1.5, it would go over here. So this is what I'm saying. You have to be able to convert it, or kind of have an idea of what that would convert to as a decimal, 4/5, without a calculator. So any ideas? Show me with your fingers what quadrant you think it's going to be in. It is in 2. You're right. So because I realize that fractions are not everybody's friend, okay? This is how I think about it. Because I know only about half of you are really understanding when it comes to this fraction. So 5, half of 5 is what? What's half of 5? 2.5. So this is kind of like saying so pi over 2, sorry, not this. Pi over 2 is kind of like saying 2.5 pi over 5. That's equivalent to 1/2. So if 4, you're asking yourself, is 4 bigger than 2.5 or is 4 smaller than 2.5? If you're looking at the numerator, okay? All right, last one. All right, go ahead and copy this one down. We got 11 pi over 6. All right, go ahead, label your quadrants, figure out where is that angle going to fall. 11 pi over 6. Positive 11 pi over 6. Show me with your fingers. What quadrant do you think we're going to fall in? 11 pi over 6. I got about 4 people, 3 people. All right, so again, if we were to write this in terms of 6, this is the same as saying 0 over 6. What is half of 6. 3. So in other words, we're counting by 3. So pi over 2 is the same as 3 pi over 2. 6 pi over 6 is the same thing as pi. 9 pi over 6 is the same thing as 3 pi over 2. And then 2 pi can be written as 12 pi over 6. This is so raggedy. This little thing is so raggedy. I keep saying it. So if my initial side is here, I'm going to go past 3, past the 6, past the 9. I'm going to end up right back here. Almost to the end. It almost wrapped around completely. So 11 pi over 6 is like right here. That would be that angle. Any questions about that?
No.
Yes.
On the test, you said you only would like grade it if like we're in the right quadrant.
Right, as long as you're in quadrant 4.
Okay.
That's it. That's really what I'm looking for. Are you in quadrant 4? All right, I want to give you a couple more. And then we'll talk about coterminal angles. All right, so go ahead and add this down. Negative 5 pi over 4. And negative 13 pi over 8. Wait, I don't know if I want to do 13. Hold on. Let me think about that one.
Is this supposed to be negative 1 pi over 8?
No, I'm thinking.
Oh,
I'm
okay.
thinking, sorry. 9 pi. All right, go ahead and graph those two. Write these down so I don't forget what I did in my other classes. So you kind of just have to think about it because we don't have the luxury of a calculator. We can't just do 9 divided by 8 and see if we get a number bigger than 2 or, you know.
Like around the circle, when you go from 0 to negative pi over 2, is that counting by halves?
Yes, radians are counting by 1/2.
So after 3 pi over 2, we go to
Wait, I'm sorry, y'all. I'm gonna change that from negative. Sorry. I'm so sorry, y'all. I'm so sorry. I just had a realization. Negative 3 pi over 8. And I'm done. I promise. I'm not gonna change it no more. I'm not gonna change it no more. Not gonna change it no more. Okay, sorry. Can you repeat your question?
So after we go from negative 3 over 2, and we get to 0.
Or we get back to 2. So it goes 0, 1/2, 1, 1.5, 2. 0 and 2 are at the same place. 0 and 360 are at the same place. So 0 and 2 pi are at the same place. That's pretty good. That's pretty good. I can't even hold you. That's pretty good. Okay, so show me with your fingers negative 5 pi over 4. What quadrant do we land in? Negative 5 pi over 4. Y'all seem scared. Everybody just gonna put up their fingers. I just want to see where we at. All right, it is quadrant 2. It is quadrant 2. So this is 0. This is negative pi over 2. This is negative pi. This is negative 3 pi over 2. And 0 is the same thing as negative 2 pi. Okay, so 5 over 4, anytime your numerator is bigger than your denominator, we should know that that's greater than 1, right? So we automatically know it's not going to be in 3 or 4. It's either going to be in 2 or 1. But if you're counting, if you were to write this as with the same denominator, this would be 6 over 4. 6 over 4 is equivalent to 3 over 2. 5 is less than 6, which is why this is my initial side. It's going to be somewhere in here. And again, as long as you're in quadrant 2, that's all I'm looking for. When I grade your quizzes, did you put it in the right quadrant? That's all I'm looking for. No, you need one of those. No, just right quadrant. That's all. All right, negative 3 pi over 8. Show me with your fingers. What quadrant?
Quadrant.
Okay. Quadrant 4. So I need to erase this. Sorry, I just need my space. So again, this one is negative. So we're going to count 0, negative pi over 2, negative pi, negative 3 pi over 2, and then this is negative 2 pi. 1/2 is the same as weird. 1/2 is the same as 4 over 8. But 3 is less than 4. So it's going to start here. It's not going to swing past that pi over 2. So this would be my terminal side. So the terminal side would be somewhere in quadrant 4. Yes.
That's my question. It goes from 0 to 1/2 to 2.
So you're counting the wrong way. So 0, 1/2, 1, 1.5, 2.
Oh.
So we're going, yeah. 0, 1/2, 1, 1.5, 2.
So we're counting by halves. So
Counting by halves, pi over 2. All right, any questions? All right, so now we're going to talk about coterminal angles, and then we'll end there. Okay, so go ahead and copy down this definition for coterminals. Coterminal simply means that they share the same terminal side. If it's in degrees, we add or subtract 360 because that's 2 pi. Or that's a full revolution. In degrees, 1 full revolution is 360 degrees. But if it's in radians, we add or subtract 2 pi. So I'm going to give you a minute to copy that down, and then we'll practice with that a little bit. So kind of like co-workers work at the same place. The prefix co means same. So coterminal means it has the same terminal side. So if you do more than 1 revolution, so we're not limited to just 360. Or 2 pi. You could do more than 1 full revolution. All right, anybody need more time to copy down the definition? All right, here's our last example. So we're gonna just copy down A though. Don't copy down B, C, and D. We're gonna do these one at a time. So I'm gonna reword this so it's worded the same as the quiz. What you have to do for a 50-degree angle is I want you to tell me a positive coterminal and also a negative coterminal, but we're also going to graph it. So I'm going to go ahead and draw my coordinate plane off to the side. And you don't have to keep labeling it. I mean, the more you get comfortable, you'll just kind of know what these are. I'm just putting it here because this is only our second day. So where would 50 degrees fall? In what quadrant would 50 degrees fall? 1, yep. So this is my initial side. The terminal side is going to be somewhere in here. So let's say though, like this, if this is a street, if I go around the circle another time and I still in there. So this would represent me going around, this is a track, for example. This would represent me going and only going just a little bit and stopping. But what if I went around the track one whole time and then still in it there? That's what adding the 360 represents. So what I want you to do, to find your positive, you're going to add 360. And yep, we got to do this old school. I always put the bigger number on top. And then you have to do the same thing. You have to do 50 minus 360 without a calculator. So what you're going to do is you're going to take, so let's start off with that. Go ahead and do that. So do your 50, 360 plus 50, and then you're going to do 360 minus 50. So even though I reverse the order, just know your answer is going to be negative because we are taking away a bigger number from a smaller number. So go ahead and do that. So your positive angle and your negative angle. So go ahead, take a minute. See if you can figure out what those two angles are. No calculator, 360 plus 50, 360 minus 50. Subtraction is just the distance between two numbers. So what's the distance between 50 and 360 on the number line? But because we're going to the left, it's a negative answer. So when you do it the first time, you have our 0, and then it's 6 plus 5, which is 11. Carry the 1. 1 plus 3 is 4. 410 degree. A 410 degree angle is going to have this exact same terminal side. The difference with a 410 degree angle is that it goes around and loops more than once. That's the difference. Does everyone see that? All right, so now let's do 360 minus 50. So we got 0 minus 0, 6 minus 5, 1, bring down the 3. But that's a negative 310 degrees. So in other words, if I try to rotate this direction and I end here, that would be a negative 310 degree angle. So what we had to do, you have to do 3 things. This is like a 3-point question. Number 1, did you graph it right? Number 2, did you give me the right positive coterminal? And did you give me the right negative coterminal? All right, let's do that with a different one. Let's look at B. No, because if it's in degrees, we're going to do it in degrees.
So you have lines that start at 360 and end up at the point, or that 50-degree mark?
Yes.
But it'll be 3 lines, right?
No, they're all at the same spot. They're all going to end up at the same place.
I'm confused.
Okay, well, let's focus in on B. We'll do this one together. All right, so let's look at B. First thing we're going to do is graph it. So 165. So this is my initial side. Where is 165 going to fall? Which quadrant is 165? It's in 2. So, oops, wrong thing. So this would be my 165-degree angle. So when I say coterminal, I'm saying, what if I go around the circle more than once? What would be another angle that will still end at this exact same spot? So we watching something, but you said you was confused. But yeah, we got our phone out. Okay. So if we go around if we go around the circle one full time and then keep going and end at this exact same spot, that's the same as saying we added 360. I added a full revolution. So a positive, to get your positive angle, you're going to take 165 plus 360. And to get your negative angle, you're going to do 360 minus 165. But remember that your answer is going to be negative. When you're doing subtraction, the one with the highest absolute value has to go on top. So my positive angle, I have 5 plus 0, which is 5. 6 plus 6 is 12. Carry the 1. 1 plus 1 plus 3 is 5. This would be my positive angle. So this has the exact same terminal side as what we drew. If I asked you to draw a 525-degree angle, it would be exactly where I put this angle. It's the same. Co means same. So now let's subtract. So we can't take 5 away from 0, so we gotta go next door. That becomes a 5. This becomes a 10. 10 minus 5 is 5. We can't take 6 away from 5, so we got to knock this down to a 2. This becomes a 15. 15 minus 6 is 9, bringing down to 2. But this is negative, though. So we're really doing 165 minus 360.
Wait, it's 1.
Oh, what did I do? What did I do?
It's 2 minus 1. Instead of
Oh, it is 2 minus 1. Thank you. Thank you so much. So 2 minus 1 is 1. But this has to be negative. I just did not see that 1 there. So it'd be negative 195. All 3 of these angles, here, 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 they're at the same place as that. That's what co means. Co means the same. All right, so now let's talk about it in radians.
So you don't have to graph those actual numbers, right?
We already did graph it. That's what I'm trying to say.
Oh, okay. That makes sense.
It's the same. Co is the same. Okay, so now let's go ahead and do C, which is in radians. So that's what you just asked me about, the radians. So first thing we're going to do is graph it. We need to figure out where does 8 pi over 5 fall. That's our first step. So we know that 8 over 5 is bigger than 1. So we have to be in quadrant 3 or 4. So we just need to figure out which quadrant would it be in. Do you think 8 divided by 5 is more than 1.5 or less than 1.5? So this one's kind of tricky. Show me with your fingers what quadrant you think this is going to be in. Oh, not many people. Ain't nobody participating. What happened to my participation? All right, let's count by halves. What's half Ooh. What's half of 5? 2.5. So this would be, if we were to write this as a fraction, this would be 0 over 5. So this would be 2.5 over 5. So I'm adding 2.5. And this would be 5 pi over 5. What's 5 plus 2.5? 7.5 over 5. So you kind of have to think of it as equivalent fractions. And then this would be the same as 2 pi. So now let's ask yourself, is 8 more or less than 7.5? More. So what quadrant am I going to fall in? 4. It's right here. That's my angle. All right, so now instead of adding and subtracting 360 in radians, that means I have to add and subtract 2 pi. So I have to take 8 pi over 5 minus 2 pi. Now you know that in order to add or subtract fractions, what do you have to have? A common what? Denominator, which means I need to multiply this fraction top and bottom by 5. So what we have is 8 pi over 5 minus 10 pi over 5. That's my negative angle. And then for our positive angle, I have 8 pi over 5 plus 10 pi over 5. So go ahead and take 8 minus 10 and 8 plus 10. That would be your positive and your negative angle. So 8 minus 10 is negative 2. So that would be my negative angle. 8 plus 10 is 18. And that would be my positive angle. All right, last one, copy down D. D is positive 5 pi over 4. You need to graph it and then give me a positive and a negative coterminal angle. Show me with your fingers. Wait, I gotta figure it out myself. Okay, I got it. With your fingers, what quadrant would this be on? What'd you say?
Was the starting point 0 pi over, was it 0.5 starting point, or what did you say it was?
I have to look at it. I erased it. I can't go back. Sorry. But I can look at your paper at the end and see if I can figure it out. Okay, so 5 pi over 4. Okay, I forgot it. Wait, okay, I got it. What quadrant?
3.
Yep, it's in 3. So again, if you're counting by 4, this would be 0 over 4. What's half of 4? 2 over 4. So we're counting by 2s. This would be 4 over 4. This would be 6 over 4. This would be 8 over 4. You do not need to do this extra work, but I'm just trying to help people who have a hard time understanding fractions. So we have to look at this numerator, 5, and figure out where does it fall. It's going to fall between 4 and 6. So we're in quadrant 3. So this is my terminal side and my initial side. That's my angle. So I want you to really quickly take 5 pi over 4. I want you to add 2 pi and subtract 2 pi. How am I going to write pi though? 2 pi so that it has a common denominator. What is it? 8 over 4. Because right now this is 2 over 1. Now my common denominator is 4, so I'm multiplying top and bottom by 4. So it's 8 pi over 4. All right, so go ahead, take 5 plus 8. That gives you 13 pi. That's my positive angle. And what's 5 minus 8? Negative 3 pi over 4. All right, we're going to end there. Good work.
Those positive, negative, or would you say that?
Well, I'll know because 13 is positive and the 3 is negative. So you don't necessarily have to. If it's a positive number, that means it's positive. If it's a negative number, that means it's negative.